Yet another type of calculation we'll do in this chapter is called a limiting reactant calculation. Now, the big difference between a regular stoichiometry problem and a limiting reactant problem is that the word excess isn't going to be used anymore. It's going to be replaced with an actual number. So limiting reactant calculations often have more than one number on the left side of your chemical equation. And you need to decide which reactant is going to run out first, and thus limit the amount of product that you're going to be making. You can't really make any more product than what your smallest amount of reactant can provide. As soon as you run out of one of those reactants, the chemical reaction shuts down, production of the product stops, and the chemical reaction is over. So you'll often find that the limiting reactant makes the smallest amount of product. Let's get right into an example. Let's actually use a similar example of what we had from before. This is our sodium chloride example, and previously the problem had read that we had 25 grams of sodium and an excess of chlorine. But now we're going to substitute with 25 grams of chlorine. Again, just like every other single problem that we're going to start with, we need a balanced chemical equation, just the same as what we had before. And underneath that balanced chemical equation, I want to list the information that I know about the problem. I'm given both 25 grams of sodium and 25 grams of chlorine, and the problem's asking for me to calculate the number of grams of sodium chloride that are produced. Now, in essence, what I'm going to really need to do is to try and figure out which reactant runs out first, which reactant produces the smallest number of grams of NaCl. That implies that I'm going to have to figure out how many grams of NaCl can be made from my 25 grams of Na, and I'm going to have to try and figure out how many grams of product can be made from my 25 grams of Cl. That sounds like two stoichiometry problems to me. So let's get started. So I'm going to do side-by-side stoichiometry problems where you notice that I applied the givens and I put them over one. I put them both in their own stoichiometry problem. My end goal is to end up with grams of my product. So we're going to follow our good stoichiometry technique, and the very first step that we'll do in our problems is convert these amounts of grams to moles. Now I'm ready for my mole to mole ratios. So again, moles of the material I want to get rid of goes to the bottom, and moles of the material that I want go to the top. And notice that this is the same for both problems. Moles of NaCl, moles of product. This is excruciatingly important. You cannot convert to two different materials and expect the numbers to make any sense. The idea here behind this style of limiting reactant problem is that your limiting reactant will limit how much product you make. If you don't calculate to the same product, you won't be able to compare your numbers. Don't forget also that the numbers for a mole to mole ratio come directly from the balanced chemical equation. So I know that the arrows look a little bit confusing. We'll pause here for just a second. Notice that all of the coefficients are going to kind of drop down into the correct positions inside of the problem. And here they are. Last step will be to convert the moles of NaCl back into grams again. And only the unit and substance drop down. Remember from before that when you're converting between moles and grams, the only allowable number for moles is 1. The only place that the number in front of mole can be anything other than 1 is in your mole to mole ratio. So we'll finish up with the molar mass of NaCl, and now it's time to plug and chug twice. So here are my two answers. Now what the heck does this mean? Well, it means in a perfect world, my 25 grams of Na, if I had all the Cl in the world that I needed, would be able to make 63.5 grams of product. However, my 25 grams of Cl if I had all the Na in the world that I would need, is only able to produce 41.2 grams of NaCl. What that means is that the 41.2 grams of NaCl is the correct answer. It's the limited answer. It's the smaller answer. We're going to label this the theoretical yield. The chemical that made this material, the reactant that made this material, is called the limiting reactant. It has limited how much product I can make. And finally, we will call the Na the excess reactant. It did not limit how much product I can actually make. And unfortunately, the answer that it provides, the 63.5 in this case, is absolutely bogus. It doesn't give us any information. It is a wrong answer and is no longer useful in any further calculations. Whenever you're doing a limiting reactant calculation, it is important at the end that you very clearly define your theoretical yield, your correct answer, and that you identify your limiting reactant and your excess reactant. The biggest tip I can give you here too is that every subsequent calculation, any other calculation that you're going to do with this data is going to spring forward from the limiting reactant. It's almost like that 25 grams of sodium doesn't exist anymore.